Hey everyone, my name is Mateus, welcome back to my channel. And well, in last video we talked about binary search, which is a very efficient algorithm when you need to find elements in arrays. But it only works under one condition, that is that we need to have our array sorted. So in this video we're going to talk about merge sort, a very powerful technique that's both efficient and elegant to sort arrays. So let's get started. Merge sort is a divide and conquer algorithm, which means that we're going to divide our problem into smaller subproblems, we're going to solve them and then merge them back together. It is incredibly efficient with a time complexity of O n log n, which makes it faster than most sorting algorithms like bubble sort, insertion sort, and selection sort. We'll first break down on how it works, and then we're going to visualize it with a visual example. Finally, I'm going to show you how you can implement them in C and JavaScript. By the end of the video, you'll have a solid understanding on how it operates and how to implement them in your code.
All right, now let's take a look at how merge sort works step by step. First of all, we're going to divide our array into smaller arrays. So in this case, we're going to divide it into arrays. Here, we're going to have this array, and we're going to have this array. Fine. We do not know how to sort 4-element arrays, so we will have to divide it again. We're going to have an array here, and we're going to have an array here. Again, we do not know how to sort 2-element arrays, so we're going to divide it into separated arrays here. And arrays with only one element, we know how to sort. So in this case, we're going to get them here, and we're going to compare 38 with 27. Which one is smaller? In this case, 27 is going to be smaller, so we will put it before, and we're going to sort the array this way. We're going to have 27, and we're going to have 38. Okay, this part is sorted. So we're going to the second half here. We do not know how to sort 2-element arrays, so we're going to divide them into separated arrays with only one element each. In this case, we're going to compare these two arrays here. We're not going to worry about them anymore. We're going to worry about them, 43 and 3. Which one's smaller? So in this case, we know that 3 is smaller than 43. Fine, we have it sorted. Now we need to merge them. And how do we do it? We're going to compare the first element of each one. I'm going to have an array here. We're going to compare 27 with 3. 3 is smaller, so we're going to put 3 here. 27 with 43, 27. 38 with 43, we're going to have 38 here. The only element that's left is 43. Fine. This half of the array, this half here, is sorted. Let's do the same with the second part. We're going to divide it here, and we're going to divide it again, and we're going to compare. We're going to compare 9 with 82, and it is already sorted. 9, 82. Sorted. And we're going to compare with this only one element left here, number 10, that is already sorted. We're going to have 10 here. And now we're going to compare the first element of each array, and we're going to have here 9 and 10, 9 smaller, 82 and 10, 10 smaller, only 82 left, 82. So this second half of the array here is already sorted, and we have two smaller arrays sorted. And we're going to do the same. We're going to merge them, and we're going to have here 3 and 9. 3 is smaller. 27 and 9. 9 is smaller. 27 and 10. 10 is smaller. 27 and 82. We're going to have 27. 38 and 82. 38. 43 and 82, and only 82 left, so we're going to have here 82. That's how merge sort works, visually seeing it. And now let's dive into the code example.
Well, now I'm going to show you two possible approaches. The first one's going to be here in C, and the second one's going to be in JavaScript, okay? So in this first case, I divided the problem in two functions. I'm going to use the merge sort function. That's actually going to divide our problem in two and recursively call merge sort for the left half and the right half. And the merge sort is the function that's going to actually merge the arrays in a sorted way. Okay, so we're going to receive this array with a lot of integers, and we're going to call the merge sort function, which is going to receive these arguments. It's going to receive the array where we are going to sort it, the left pointer and the right pointer. And if the left pointer is less than the right pointer, it means that the array has at least two elements. Because if both are the same, or right is less than left, it means that the array has 0 or 1 element, which means that we do not need to sort it because it is already sorted. So in this case, we're going to define that middle is going to be left plus right minus left divided by 2. And we're going to recursively call merge sort for the left and for the right halves of the array. And after we got them sorted, we're going to merge them again in a sorted way. And we're going to do it like recursively for all of the array. Fine. And so let's dive into the merge function here. We're going to receive the array, so the same array again. We're going to receive the left pointer, the middle pointer, and the right pointer. To start it, we're going to get three variables. We're going to get I, j, and k. And we're going to define the number of elements in each one of the arrays. We're going to define the number of elements in the left array and in the right array. The number of elements in the left side of it is going to be defined as mid minus left plus 1, and the number of elements in the right side of it is going to be defined as right minus mid. After we got the pointer set, we know how many elements we're going to have for each one of the arrays. We're going to fill them. So we're going to create both of the arrays, and we're going to fill them with the elements from the original array. So at this point of the code, we already have two arrays, and now we only need to merge them. That is the easier part. So we're going to reset those variables to 0. So I and j are going to be set to 0, and we're going to get one more variable that's going to be set to left. That defines where in the original array we're going to start the merging part. Okay, so while I is less than the number of elements in the left array, and while j is less than the number of elements in the right array, we're going to compare them. So if the first element in the left half is less or equal to the first element of the right half, we're going to put the left element first, and we're going to do it all the way. So we're going to always increase the variables so we can keep going through the arrays. And after each iteration, we're going to increase the key pointer here too, because we need to keep going through the original array. So after it, if there is any element left in the left array or in the right array, we're going to just keep putting them on the original array. Finally, here I have a print array function, but it is not important. It's just a loop that's going to print each one of the elements here. Now I will show you how it works. Let me open the terminal here. We're going to run this. I have already made the program, but I can show you. Like, you can go make merge sort. It is already up to date, and we're going to call merge sort. So as you can see, we have this unsorted array. That is the array we have here. If you compare, you can see that it is the same. And the sorted array after all the process. We can add some more elements if we want here. So we can elements, for example, we can add, for example, 11, we can add 12, we can add 500, we can add, I don't know, 6. I don't think we have 6. Yeah, I don't think so. And maybe 101 and 1000, for example. So we're going to again make merge sort. We're going to call merge sort, and we have the array sorted again. So it is how it works in C. Now I'm going to show you the approach in JavaScript, which is a little bit different because we are not going to change the original array. We're going to return a brand new array here. So we have two functions here, just as we did in C. We have the merge sort function and the merge function. So the merge sort is going to check for the size of the array, the length of the array. We're going to call recursively the merge sort for the left array and for the right half of the array. And we're going to return them merged. And the merge function is going to work pretty equal to the last case we saw. But in C is a little bit more difficult to do it because those languages are very, very different. So we're going to set I, we're going to set j, and we're going to have the result array, which we're going to merge them into this array and we're going to return it. So while I is less than left.length and j is less than right.length, we're going to compare the first element of each one of the arrays and we're going to merge, just as we did in C. So I hope it is clear, guys. If you have any doubts, if you have any questions, you can leave them in the comments, right? So this is how merge sort works, both in C and JavaScript. You can see that the structures are pretty the same. We're going to split the arrays and we're going to recursively call the merge sort function for both the left and the right halves, and then we're going to merge them back together. Merge sort is great for you that's trying to understand recursion and divide and conquer algorithms. I hope you find it useful and be sure to like, subscribe, and hit the notification bell. I hope to see you in the next video.